The universe has always been a place of profound silence and deep unfolding mystery. For as long as we have looked up at the night sky, we have wondered if we are the only ones looking back. We have stared at the twinkling lights of distant stars, wondering if, around one of those points of light, there is a world not unlike our own. A world with oceans, with winds, and perhaps with the gentle pulse of life. For centuries, this was the domain of poets and dreamers. We had no way to reach out and touch the atmosphere of a world light years away. We could only imagine. But the era of imagination has begun to give way to the era of observation. Far beyond the reach of Earth's shimmering atmosphere, a quiet sentinel hangs in the cold, dark void of space. The James Webb Space Telescope, a masterpiece of human ingenuity and patience, sits at a point of perfect balance, nearly 1,000,000 miles from our home. It does not see the world as we do. It does not look for the bright, visible colors of a sunset or the deep blue of a sea. Instead, it looks into the infrared, the realm of heat and invisible energy. It looks for the faint, warm glow of the distant past and the subtle chemical whispers of worlds we can barely conceive of. Recently, this quiet sentinel turned its golden mirrors toward a specific patch of darkness. It focused its gaze on a star that, to the naked eye, would be entirely invisible, a small, cool red dwarf burning with a steady, ancient flame. And there, orbiting within the gentle embrace of that star's light, it found something that has changed the course of our history. It found a planet. But it was not just any planet. As the data began to stream back to Earth, a picture started to emerge that was so consistent, so clear, and so compelling that it pointed toward a staggering conclusion. According to the most rigorous models we possess, there is a 99.7% chance that this distant world is not a wasteland of rock and ice, but a living, breathing biosphere. When we speak of a 99.7% chance, we are speaking of a level of scientific certainty that is rarely seen in the field of exoplanetary research. It is a number that suggests that all the variables have aligned. It suggests that the water we hoped for is there. It suggests that the atmosphere is not a toxic shroud, but a protective blanket. And most importantly, it suggests that within that atmosphere there are chemicals that simply should not exist unless something is alive to produce them. To understand how we reached this point, we must first settle our minds and prepare to travel across the vast distances of the cosmos. We must leave behind the noise of our daily lives and enter the stillness of deep space. We must understand the language of light, for light is the only messenger we have from these distant shores. Every photon that strikes the detectors of the James Webb Space Telescope carries a story. It tells us about the temperature of the star it left behind. It tells us about the path it took through the void, and if that light passed through the atmosphere of a planet on its way to us, it carries the fingerprints of every molecule it encountered. This is the story of those fingerprints. It is the story of a world that exists on the very edge of our understanding, a world that may finally answer the oldest question of all. Are we alone? As we delve into the data, as we explore the chemistry and the physics of this new discovery, we do so with a sense of reverence. We are standing on the threshold of a new understanding of our place in the cosmos. The universe is no longer just a collection of cold, distant objects. It is becoming a garden, a place where life might be as common as the stars themselves. Imagine, if you will, the process of this discovery. It did not happen with a shout or a flash of light. It happened in the quiet hum of data centers and the patient analysis of researchers. It began with a dip in the light of a star. As the planet passed in front of its sun, a tiny fraction of that starlight was blocked. To an observer on Earth, the star seemed to dim by just a fraction of a percent. But in that dimming, there was a wealth of information. Some of the light did not just hit the planet, it skimmed through the very top of the atmosphere. As that light passed through the air of this distant world, the gases there absorbed specific frequencies. Oxygen, methane, carbon dioxide, water vapor. Each leaves a unique gap in the spectrum of light, like a barcode written in the stars. By reading this barcode, we can know exactly what the air of that world is made of. We can know if it is thick or thin, hot or cold, and we can look for the biosignatures, the combinations of gases that, on Earth, are the unmistakable signs of life. The 99.7% figure comes from the presence of these biosignatures in a ratio that defied every non-biological explanation the scientists could devise. They tried to find a way that volcanoes could produce it. They tried to find a way that sunlight hitting rocks could create it. They tried to imagine exotic chemical reactions in the upper atmosphere, but every model failed. Only one model remained consistent with the data, the presence of a global, active biological system. It is a thought that invites us to pause. Somewhere, trillions of miles away, the sun is rising over a landscape we will never walk upon. There may be forests that breathe, oceans that teem with unseen forms, and skies that hold the secrets of a different evolution. The James Webb Space Telescope has not just found a planet, it has found a mirror. By looking at this distant world, we are seeing the potential of our own universe to create and sustain the miracle of life. We are seeing that Earth is not a lonely accident, but perhaps part of a much larger, much older family of living worlds. To appreciate the significance of this discovery, we must look closer at the environment in which this planet exists. Our own Sun is a yellow dwarf, a bright and energetic star that has provided a stable source of heat for billions of years. But the star at the center of this new discovery is different. It is an M-dwarf, a red dwarf star. These are the most common stars in the galaxy, outnumbering stars like our Sun by a vast margin. They are smaller, cooler, and glow with a deep, ruby-red light. For a long time, scientists were skeptical that life could exist around such stars. Because they are cooler, a planet must orbit much closer to stay warm enough for liquid water. This proximity creates challenges. The planet might become tidally locked, with one side forever facing the sun and the other forever lost in darkness. The star might release frequent flares of radiation that could strip away an atmosphere. But the James Webb Space Telescope has shown us that our fears may have been misplaced. It has shown us a world that has weathered these storms and emerged with a stable, protective environment. The planet itself is what we call a super-Earth. It is larger than our home, with a stronger pull of gravity that would make a human feel heavy and slow. This extra mass is a blessing. It allows the planet to hold onto a thick atmosphere, protecting the surface from the radiation of its red sun. It also suggests a geologically active interior, with plate tectonics and volcanic activity that could recycle nutrients and maintain a stable climate over billions of years. In the red light of its sun, the surface of this world would look very different from our own. The plants, if they exist, might not be green. They might be black or deep purple, evolved to soak up every available photon of the dim infrared light that bathes their world. The James Webb Space Telescope was specifically designed to see this light. Its mirrors are coated in a thin layer of gold, the best material for reflecting infrared radiation. When the telescope points toward this red dwarf system, it is gathering the heat of a world that is just the right temperature for life. It is sensing the warmth of a planet that is neither a frozen desert nor a boiling cauldron. It is a world in the Goldilocks zone where water can exist as a liquid, flowing over the surface and providing the cradle for life. As the data from the telescope's spectrographs arrived, the scientists began to see the signature of water vapor. This was the first great hurdle. Without water, the chances of life drop significantly. But the water was there, abundant and clear. Then they found carbon dioxide, the building block of organic chemistry. But the true revelation came when they detected the simultaneous presence of methane and oxygen. In a world without life, methane and oxygen are like fire and ice. They do not like to exist together. They react quickly, turning into water and carbon dioxide. If you find them both in an atmosphere at the same time, it means something is constantly pumping them into the air. Something is producing methane, and something is producing oxygen at a rate that keeps the atmosphere in a state of chemical disequilibrium. On Earth, that something is life. The methane comes from microbes and geological processes fueled by biological activity. The oxygen comes from photosynthesis. To find this same signature on a world around a red dwarf is the smoking gun that leads to that 99.7% probability. It is important to understand the caution with which scientists approach such a number. They do not use it lightly. It represents the result of thousands of simulations, each one testing a different possibility. They asked, could a comet have brought the methane? Could the star's radiation have split water molecules to create the oxygen? For every question, the answer was the same. These processes could explain a little bit of the signal, but they could not explain the sheer volume and the specific ratio observed by Webb. The only explanation that fits all the pieces of the puzzle is a living biosphere. The discovery has sent a ripple of quiet excitement through the scientific community. It is not the loud, frantic excitement of a breaking news story, but a deep, meditative realization. We are living in the moment when the search for life has shifted to the study of life on another world. We are no longer asking if it is there. We are starting to ask what it is like. Imagine standing on the surface of this world. The sky would not be blue, but perhaps a soft, dusty rose or a deep amber, filtered through the thick atmosphere and the red light of the sun. The sun itself would appear large in the sky, a giant, unblinking eye of copper red. Because the planet is likely tidally locked, the sun would never set. It would hang eternally at the same point in the sky. In the regions of eternal twilight, where the sun sits forever on the horizon, the temperatures might be most comfortable. There, in the perpetual orange glow of a never-ending sunset, life could have found its perfect niche. The winds on such a world would be massive and steady, carrying heat from the day side to the night side, ensuring that the entire planet remains habitable. This global circulation would create a climate of remarkable stability. Unlike Earth, which has seasons and varying day lengths, this world would be a place of constancy. The same weather, the same light, the same warmth, day after day for millions of years. This stability is a powerful engine for evolution. It allows life to become deeply tuned to its environment, creating complexities we can only begin to imagine. The James Webb Space Telescope is our window into this constancy. By observing the planet over multiple orbits, it has confirmed that the atmosphere is not changing in a way that suggests temporary volcanic bursts. It is a steady, breathing rhythm. The telescope has watched as the planet moved behind its star and reappeared, measuring the heat emitted by the planet itself. The results confirmed a world with a moderate Earth-like temperature, further solidifying the 99.7% chance. As we move forward in our understanding, we must be patient. The distances are too great for us to send a probe and take a picture of a forest or a sea. We must rely on the light. We must continue to refine our models and collect more data. But the foundation has been laid. The golden mirrors of Webb have captured a truth that was once hidden in the dark. We are part of a living universe. The silence of the stars is not the silence of an empty room, it is the silence of a library filled with stories waiting to be read. We are now beginning to read the first chapter of one of those stories. It is a story written in the language of molecules and light, told by a red sun and a golden telescope. It tells us that life is not a fragile fluke, but a resilient and persistent force that finds a way to flourish even under the light of a different sun. As we contemplate this, we feel a sense of peace. The universe feels a little less cold, a little less empty. We have found a neighbor, a distant cousin in the cosmic family. And while we may never meet, just knowing they are there changes everything. To understand why the number 99.7% has such weight, we must look into the very heart of the atoms that the James Webb Space Telescope has detected. We must look at the concept of chemical disequilibrium, a term that sounds cold and technical, but is actually the most vibrant and poetic signature of a living world. In the vast, cold emptiness of space, most things tend toward a state of rest. If you leave a mixture of chemicals alone for long enough, they will eventually react with one another until they reach a point of balance where nothing more happens. This is the state of a dead world. Mars is largely in chemical equilibrium. Venus is in a state of stagnant balance. Their atmospheres are like a song that has finished playing, leaving only a lingering, unchanging note. But Earth is different. Earth is a planet that refuses to be still. Our atmosphere is a chaotic, swirling mixture of gases that, by all the laws of simple chemistry, should not be together. We have oxygen, which is highly reactive and loves to bind with other elements. We have methane, which breaks down quickly when exposed to sunlight and oxygen. If all life on Earth were to vanish tomorrow, these gases would quickly find each other, react, and disappear from our sky. The oxygen would rust the rocks, the methane would vanish into the blue. Within a few thousand years, a mere heartbeat in cosmic time, the Earth's atmosphere would settle into a quiet, dead equilibrium. The fact that our atmosphere remains 21% oxygen is only possible because trillions of plants and microbes are constantly, every second of every day, pumping fresh oxygen back into the air through photosynthesis. The fact that methane persists is because biological processes in our oceans, our wetlands, and our soils are constantly replenishing it. Life is the engine that keeps the atmosphere out of balance. It is the heartbeat that prevents the chemical song from ending. When the James Webb Space Telescope looked at this new planet, it saw a song that was playing at full volume. The data showed a level of chemical disequilibrium that was almost identical to that of Earth. It found methane and oxygen existing in the same space at the same time in quantities that could not be explained by the slow, grinding processes of geology. This is the core of the 99.7% probability. When scientists ran their simulations, they asked, is there any way for a dead planet to act this way? They considered the possibility of massive, non-stop volcanic eruptions. They considered the impact of ultraviolet light on frozen ice. They considered exotic minerals that might catalyze strange reactions. But for every non-biological scenario, the numbers didn't add up. The volcanoes would produce too much sulfur, the ultraviolet light would produce too much ozone, the minerals would work too slowly. Only when they added life into the equation, a global, active biological presence, did the models match the data perfectly. It was as if they were looking at a distant heart beating and, after exhausting every other possibility, were forced to conclude that they were looking at a living creature. This discovery is a triumph of a technique called transmission spectroscopy. As the planet passes in front of its red sun, the starlight filters through the thin ring of atmosphere surrounding the planet's silhouette. This light travels for light years, carrying the imprint of the molecules it touched. The James Webb Telescope's near-infrared spectrograph, or NIR spec, captures this light and breaks it apart into a rainbow of infrared colors. Within that rainbow are dark lines, shadows cast by the molecules of water, methane, and oxygen. The precision required for this is staggering. It is like standing in New York and trying to see the color of a butterfly's wing in London. Yet Webb was built for exactly this level of sensitivity. Its mirrors, polished to a perfection of a few atoms' thickness, can detect the faintest dip in light, the smallest chemical whisper. And the whisper it heard from this world was a shout, "I am alive." But there is more to this story than just the presence of life. There is the nature of the world itself. Being a super-Earth, this planet has a gravitational pull roughly twice as strong as our own. This gravity acts like a giant hand, pressing down on the atmosphere, making it thick and dense. A thick atmosphere is a wonderful thing for a planet orbiting a red dwarf. Red dwarfs are known for their temper tantrums, sudden flares of X-rays and ultraviolet radiation that could strip the air from a smaller, weaker planet. But this super-Earth is a titan. Its gravity is strong enough to hold onto its air, even in the face of the star's fury. This thick atmosphere also acts as a global heat distributor. Because the planet is likely tidally locked, with one side always facing the sun, you might expect one half to be a scorched desert and the other to be a frozen wasteland. But on a world with a dense, life-rich atmosphere, the air acts like a giant conveyor belt. The heat from the day side is sucked up into massive planet-wide wind systems and carried around to the night side. This prevents the dark side from freezing solid and the light side from boiling away. It creates a planet of moderated temperatures, a world where liquid water can flow across the entire surface, from the bright center to the dark edges. We call these worlds Hycean, planets if they are covered in a global ocean, or eyeball Earths if they have a central sea surrounded by ice. The data from Webb suggests this world has a vast, deep ocean, perhaps hundreds of miles deep. In such an ocean, life would not just be confined to the surface. It could exist in a three-dimensional kingdom of unimaginable scale. The high gravity would make the water even more buoyant, allowing for massive structures and organisms that could never exist on Earth. Imagine a world where the very air you breathe is a sign of the life beneath the waves. A world where every breath of wind carries the scent of 1 billion alien microbes, all working together to keep their world in that beautiful, precarious state of disequilibrium. We are looking at a planet that is not just a rock with some things living on it. We are looking at a planet that is a single, unified living system, a Gaia on a grander scale. The 99.7% chance is a testament to the resilience of this system. It suggests that once life takes hold, it becomes the dominant force on a planet. It reshapes the sky, it alters the rocks, and it leaves a mark that can be seen across the terrifying reaches of interstellar space. As we sit here on Earth, looking through the golden eyes of our telescope, we are seeing the proof that we are not a lonely miracle. We are part of a cosmic pattern, a recurring theme in the great symphony of the universe. Let us travel now in our minds to the surface of this world. Let us imagine what it would be like to stand on a shore where the sun never sets, where the light is forever a deep, resonant amber. This is the world of the Terminator line, the thin strip of land and sea that separates the eternal day from the eternal night. On a tidally locked planet, this is where the climate is most similar to our own. It is a place of perpetual twilight, a long circular garden that wraps around the entire circumference of the planet. As you step out onto the landscape, the first thing you notice is the weight. Your body feels heavy, your every movement requiring a deliberate effort of will. The gravity of this super-Earth is a constant presence, a reminder of the planet's power. But the life here has adapted. The plants, if we can call them that, are not tall and slender like our trees. They are low to the ground, with thick, sturdy trunks and broad, sprawling leaves designed to catch every photon of the dim red light. These leaves are not green. Green is the color of a world that has an abundance of high-energy yellow and blue light. On this world, the sun provides mostly low-energy infrared. To survive, the plants have evolved to be black or a deep, velvety purple. They are perfect absorbers, drinking in the heat and the light of their copper sun. In the still air of the twilight zone, these dark forests would be silent and majestic, a sea of shadows breathing in the carbon dioxide and exhaling the oxygen that the James Webb Space Telescope detected from afar. The sky above you is a wonder. Because the sun is always at the same point on the horizon, the clouds are caught in a permanent dance. Massive storm systems, driven by the heat of the dayside, roll over the horizon and dissipate into the night. The sun itself is a giant, glowing ember, 30 times larger in the sky than our sun appears from Earth. It does not burn with a harsh white light, it glows with the warmth of a dying fire, casting long, soft shadows that never move. On this world, there are no clocks, there are no seasons. There is no tomorrow or yesterday, defined by the rising and setting of a sun. There is only the now. For the life that has evolved here, time is measured not by the movement of the heavens, but by the slow growth of the forests and the steady pulse of the tides. The ocean, pulled by the gravity of the nearby sun, would have a permanent bulge, creating a shoreline that never changes. In the waters of this world, the 99.7% chance of life becomes a 100% reality in our imagination. The oceans would be rich with minerals kept in motion by the planet-wide winds. Because the light is always coming from the same angle, the water would be stratified into layers of light and shadow that never shift. In the upper layers, dark pigmented plankton would thrive, fueling a massive food web. In the depths, where even the red light cannot reach, life might huddle around geothermal vents, much like it does in the dark trenches of our own oceans. But it is the atmosphere that holds the most intriguing possibility. On Earth, our air is mostly nitrogen. On this world, the density of the air might allow for things to fly or float much more easily than they do here. We might imagine atmospheric forests, where gas-filled organisms drift through the thick, warm air, grazing on the airborne microbes that are swept up from the surface by the winds. In the high gravity, flying requires more energy, but the thick air provides more lift. The result could be a sky filled with slow, graceful leviathans, drifting through the amber light of an eternal afternoon. As we contemplate these possibilities, we must remember that they are more than just science fiction. They are the logical conclusions of the data we have gathered. When we see a 99.7% probability of life, we are seeing a world that has all the ingredients and the right conditions to produce this level of complexity. We are seeing a world where the long now of a stable environment has allowed evolution to experiment for billions of years longer than it has on Earth. Red dwarf stars live for trillions of years. Our sun will run out of fuel in a few billion years, but the copper sun of this new world is just getting started. It is an ancient and patient star, providing a stable cradle for life that could outlast our entire solar system by a factor of 1,000. This means that the life we are sensing could be far more ancient and far more complex than anything we can conceive. It has had the time to tune itself perfectly to the rhythm of its world. There is a profound peace in this realization. When we look at the 99.7% chance, we are not just looking at a discovery, we are looking at a future. We are looking at the proof that life is a fundamental feature of the universe, a natural outcome of the laws of physics and chemistry when given enough time and the right light. The James Webb Space Telescope has pulled back the curtain on a stage that has been set for eons. As the night side of the planet remains hidden in darkness, we can only wonder what mysteries it holds. Perhaps there are bioluminescent forests that glow with their own light, creating a mirror of the stars on the surface of the world. Perhaps there are creatures that migrate from the heat of the day to the cool of the night, living their lives in a constant journey across the Terminator line. The possibilities are as vast as the universe itself. As we stand on the threshold of this new reality, we find ourselves moving beyond the simple detection of molecules and into the realm of profound, quiet contemplation. The 99.7% chance of life that the James Webb Space Telescope has revealed is more than just a scientific data point, it is a fundamental shift in the human story. For all of recorded history, we have been a species defined by our isolation. We have looked at the stars and seen a cold, beautiful, but ultimately empty stage. But now, the stage is alive. The dark spaces between the stars are no longer voids, they are the connective tissue of a galaxy that breathes. With the presence of a global biosphere virtually confirmed, our minds naturally drift to the next great question. If a world is alive, is it also aware? In the quiet halls of our observatories, a new search has begun. A search not for the chemical signatures of breathing, but for the technological signatures of thinking. If this super-Earth has hosted life for billions of years under the steady light of its red sun, what might that life have become? In a world of eternal twilight and heavy gravity, would intelligence look anything like our own? The James Webb Space Telescope is now beginning to look for technosignatures. These are the subtle signs of a civilization that has learned to harness the energy of its star. We are looking for the presence of artificial chemicals in the atmosphere, gases like chlorofluorocarbons, which do not occur in nature and can only be produced by industry. We are looking for the faint, structured heat signatures of cities or the telltale glint of orbital structures. We are looking for a light that does not belong to a star, but to a society. There is a deep, meditative patience required for this search. we must remember that we are looking at light that has traveled for decades to reach us. We are looking into the past. If there is a civilization there, they are seeing the Earth as it was years ago. They are seeing our own first tentative steps into the space age. In this way, the universe is a hall of mirrors, where every discovery is an echo of our own journey. But even if we find no signs of technology, the 99.7% discovery remains a triumph. It tells us that the great silence that has haunted our species is not a result of a lack of life, but perhaps a result of the vastness of time and space. Life is common, but the moments where two civilizations overlap may be rare. This does not make the discovery any less significant. It means that we are part of a grand, unfolding process, a galaxy that is constantly experimenting with the miracle of existence. Think of the timescales involved. The red dwarf star that warms this new world will continue to shine for hundreds of billions, perhaps even trillions of years. Our own sun is a flickering candle by comparison. If life has taken hold there, it has a future that is almost incomprehensible in its depth. While we are a species of the morning, living in the early light of a young star, the inhabitants of this super-Earth may be a species of the eternal afternoon, with a history and a future that span epochs. This discovery invites us to rethink our place in the cosmic hierarchy. We are no longer the masters of a lonely castle. We are more like children discovering that the world outside our garden is filled with other gardens, each with its own seasons, its own struggles, and its own beauty. The high gravity of that distant world may have kept its inhabitants grounded, perhaps preventing them from ever leaving their atmosphere. They may look up at their red sun and wonder about the yellow star in their own sky, never knowing that we are here, looking back at them with our golden mirrors. The James Webb Space Telescope has fulfilled its greatest promise. It was built to see what was previously invisible, to hear what was previously silent. By focusing on the infrared, it has pierced the veil of the dark and found a world that is 99.7% likely to be a brother to our own. This number will be refined, of course. Scientists will continue to gather more data, to test more models, and to search for even more specific clues. But the weight of the evidence has already tipped the scales. The universe is no longer a mystery to be solved, it is a community to be joined. As we conclude this journey, let us return to the image of that quiet sentinel, hanging in the dark, 1,000,000 miles away. Its golden mirrors are still cold, still precise, still watching. It is a monument to our curiosity, a testament to our refusal to accept that the silence of the stars is the final answer. Because of Webb, we now know that somewhere across the vast and velvet night there is a shore where the sun never sets. There is a sea that breathes under a copper sky. There is a world where the chemical heartbeat of life is as steady and as certain as the laws of gravity. We started with a question: are we alone? And while we may not have a voice to answer us yet, we have the light, we have the data, we have the 99.7% certainty that the miracle of life is not ours alone to keep. It is a gift that the universe gives to itself, over and over again, around every red sun and every yellow star. When you look up at the night sky tonight, do not see the darkness, see the potential. Know that for every point of light you see, there are worlds we are only just beginning to understand. Know that the silence you hear is not emptiness, but a pause in a much longer conversation. We have found a world that lives. We have found a neighbor. And in doing so, we have found a little more of ourselves. The journey of the James Webb Space Telescope continues, and with it, the journey of humanity. We are no longer just observers of the cosmos, we are participants in its awakening. The universe is alive, and for the first time in our history, we have the proof. We can rest in the knowledge that we are part of a living tapestry, a vast and beautiful garden that grows under the light of 1 billion different suns. The 99.7% chance is our new beginning. It is the first word in a new chapter of the human story, a story that is no longer about one world but about all worlds. Rest now, and let the image of that red sun and those dark, breathing forests settle in your mind. The universe is a home. It is a garden. And we are, finally, no longer alone.